Welcome to Science for Sleep. Tonight we're going to slow everything down. No rush. No pressure to remember anything. Just curiosity, gently drifting. As you settle in, allow your breathing to soften. Nothing forced. Nothing controlled. Because the question we're exploring tonight is one that doesn't demand answers right away. It simply invites wonder. Are dreams just simulations? Entire universes our brains quietly run while we sleep? And if they are, what does that say about consciousness, reality, and the universe itself? Every night, without effort, your mind constructs worlds. Not vague images, not random noise, but environments, places with gravity, with physics, with continuity. You walk through rooms you've never seen yet somehow recognize. You meet people who feel real, emotionally real, even when they don't exist. You experience fear, joy, movement, and time. And while you're dreaming, it all feels completely real. That alone raises a strange possibility. If the brain can generate entire realities during sleep, how different is that from a simulation? To understand this, we need to begin with something simple. Not dreams, but simulation itself. A simulation is not a fake thing. It's a model, a system that recreates the rules of another system. Flight simulators recreate the physics of air. Weather models recreate atmospheric behavior. Video games recreate entire worlds governed by internal logic. What matters isn't realism, it's consistency. And your dreams are remarkably consistent. During REM sleep, your brain becomes almost as active as it is when you're awake. In some regions, it's more active. The visual cortex lights up. Emotion centers like the amygdala surge. Memory networks begin replaying and recombining experiences. But the part of your brain responsible for logic and skepticism, the prefrontal cortex, quiets down. That's why absurd things feel normal in dreams. Your brain isn't asking, "Does this make sense?" It's asking, "What happens next?" And that's exactly how simulations work. Neuroscientists increasingly believe dreams are not random. They are predictive models. Your brain constantly tries to predict reality while you're awake. Dreaming may be the same process, just unplugged from sensory input. Instead of reacting to the world, your brain runs its own version of one. A closed system, a test environment, almost like a sandbox universe. Some researchers call this the threat simulation theory. The idea is that dreams evolved to simulate dangerous or emotionally charged scenarios. Being chased, falling, losing someone. Your brain rehearses survival without real-world risk. But over time, the theory expanded. Dreams don't just simulate threats. They simulate social interactions, moral choices, identity, and even alternate versions of yourself. Which leads to a deeper question. If dreams are simulations, who is the character inside them? When you dream, there is still a you. You perceive, you decide, you feel continuity. That suggests something extraordinary. Your sense of self does not require waking reality. It only requires a coherent world model. This is where neuroscience quietly brushes against philosophy, and where things begin to feel unsettling. Philosophers have long asked, how do we know we're awake right now? In dreams, we rarely question reality. Everything feels normal until we wake up. So what if waking life is simply another layer of simulation? Not necessarily artificial, not necessarily designed, but generated. Some neuroscientists argue that consciousness itself is a simulation, a controlled hallucination. Your brain doesn't show you reality. It predicts it, then corrects errors using sensory input. In dreams, the correction step is removed. The prediction runs freely, which means your dream world isn't fake. It's simply unchecked. This idea connects to one of the strangest modern theories of consciousness, predictive processing. According to this model, your brain is not a passive receiver of information. It's a prediction engine. It constantly guesses what reality should look like, then updates those guesses based on incoming data. Dreaming may be what happens when the guessing continues, but the data stops. A universe without external input. A simulation closed off from base reality. And here's where it gets interesting. In physics, there's a growing idea that our universe itself may operate the same way. Not as a dream, but as an internally consistent information system. Which raises a question so strange it almost feels forbidden. Are dreams miniature versions of how universes are born? Some cosmologists speculate that universes may emerge from fluctuations in quantum fields. Tiny rule sets, tiny initial conditions, expanding into fully formed realities. Your brain does something similar every night. A few memory fragments, a few emotional states, suddenly becoming a world. And if that's true, then dreams aren't meaningless. They're demonstrations. Proof that reality, at least locally, can be generated from information alone. Now take a slow breath, because from here we're going to move deeper. Next we'll explore whether dream characters have independent minds, why time behaves strangely in dreams, lucid dreaming as simulation awareness, ancient cultures that believed dreams were other universes, and the conspiracy theories that suggest dreams are not entirely internal. But we'll move slowly, gently, one idea at a time. For now, just let the thought rest. Every night, your mind creates a universe and steps inside it, and it does so without effort, without machines, without technology, just consciousness, just imagination, just simulation. As you rest a little deeper, there's something subtle worth noticing. In your dreams, you are never alone. There are others. They speak, they react, they surprise you, and often, they seem to know things you don't. Dream characters are one of the strangest features of the dreaming mind. They argue with you, they comfort you, they deceive you, they teach you. And while you're dreaming, they feel independent, as if they have their own thoughts, emotions, and intentions. This raises a deeply unsettling question. If your brain is generating everything in the dream, who is thinking for them? Neuroscientists know that dream characters are constructed from fragments of memory, personality models, and emotional expectations. But that explanation doesn't fully satisfy the experience. Because dream characters don't just repeat known behavior. They improvise. They respond creatively. Sometimes they even say things you've never consciously thought before. Which leads some researchers to describe dreams as multi-agent simulations. One brain, many minds. From a computational perspective, this is extraordinary. Your brain is not only simulating an environment, it's simulating other consciousnesses within it, each with believable reactions, each governed by consistent emotional logic, which means your mind is capable of running a society while asleep. This mirrors something we see in artificial intelligence research. Complex simulations often become more realistic when populated with autonomous agents, non-player characters, independent decision makers. In dreams, your brain does this naturally, and it does it efficiently. No lag, no rendering delay, no loading screens, just presence. Now consider something else strange. Time. Time in dreams behaves differently. An entire lifetime can pass in minutes. You can skip years between moments. You can relive the past and anticipate the future simultaneously. Yet while dreaming, time feels perfectly normal. Only upon waking do you realize how distorted it was. Studies show that during REM sleep, the brain's internal clock becomes highly flexible. Instead of tracking objective time, it tracks narrative time. What matters is not duration, but meaning. Events expand or compress based on emotional weight, which is exactly how time behaves in stories and simulations. In fact, physicists describe time in our universe in a surprisingly similar way. Time may not be fundamental. It may emerge from change, from cause and effect, from information updating itself. In dreams, the same principle applies. Time exists only because the simulation continues. This leads to an unsettling parallel. If time feels real inside a dream, and reality feels real while awake. What makes one more valid than the other? Philosophers have struggled with this question for centuries. René Descartes famously doubted everything except his own awareness. I think, therefore I am. But modern thinkers push the question further. If awareness alone defines reality, then dreams qualify. This is where lucid dreaming enters the picture. Lucid dreaming occurs when the dreamer becomes aware they are dreaming. The simulation continues, but awareness steps outside the script. You realize the rules can bend. Gravity becomes optional. Walls become permeable. Time becomes negotiable. Lucid dreamers often report something remarkable. The world doesn't collapse when they question it. Instead, it becomes more stable, more detailed, more responsive, almost as if the simulation welcomes observation. Some researchers believe lucid dreaming is the brain testing its own models. A feedback loop, a system becoming aware of itself, which mirrors something else entirely. The universe observing itself through consciousness. In physics, there is a long-standing mystery. Why does observation matter? In quantum mechanics, systems exist in probabilities until they are measured. Then they collapse into a definite state. No one fully understands why. But some interpretations suggest that consciousness plays a role, not as a mystical force, but as an informational boundary. In dreams, observation works the same way. Unnoticed details remain vague. The moment you look closely, they sharpen. Your attention stabilizes the environment, just like a rendering engine allocating resources, which leads some thinkers to propose a provocative idea. Dreams are not just internal experiences. They are miniature demonstrations of how reality itself might function. Not proof, but analogy. Ancient cultures believed this deeply. The Aboriginal Australians described the dream time as the foundation of reality itself. The ancient Greeks believed dreams were messages from beyond the physical world. Tibetan Buddhism treats dreams as training grounds for navigating reality after death. Across cultures, dreams were never dismissed as meaningless. They were considered other layers of existence. And then there are the conspiracies. Some believe dreams are shared spaces, that consciousness temporarily overlaps, that recurring dream locations, places many people report visiting, are not coincidence, that dreams are not entirely private. Science finds no evidence for this, but the persistence of the belief is telling, because something about dreams feels larger than the self, as if the mind is tuning into something rather than inventing it, as if the simulation isn't entirely closed. Now don't try to answer that. Just notice the feeling, the curiosity, the quiet uncertainty. In the next part, we'll go even deeper. We'll explore the idea that dreams are evolutionary training grounds, the possibility that consciousness itself is layered, why some scientists think reality behaves like a dream, and whether waking life could be just the most stable simulation of all at a pace designed to let your thoughts drift. For now, let your awareness soften. Let the questions float. Nothing needs to be resolved. Nothing needs to be understood fully. Just let the universe your mind creates continue unfolding. As the dream continues to unfold, there's a deeper question quietly waiting underneath everything we've explored so far. Why does the brain do this at all? Why build entire worlds when it could simply rest? From an evolutionary standpoint, dreaming appears strangely expensive. The brain burns nearly as much energy during REM sleep as it does while awake. Heart rate changes, breathing patterns shift, neural networks fire rapidly and unpredictably. This is not passive rest. This is active construction. One of the leading scientific theories is that dreams are prediction training. Your brain is constantly trying to anticipate the future, where danger might appear, how others might behave, what outcomes follow which choices. While awake, it trains using reality. While asleep, it trains using simulation. In this sense, dreams are rehearsal spaces, safe environments where mistakes don't cost survival. You fall from heights. You run from threats. You practice conversations, confrontations, escapes, and your brain learns from each one, even if you don't remember it. Neuroscientists have observed that the same neural circuits used for perception, movement, and emotion while awake are activated during dreams. The difference is not the machinery, it's the input source. Instead of sensory data from the outside world, the brain feeds itself internally generated information. A closed-loop universe. This begins to resemble something familiar in physics. A self-contained system governed by internal rules. A miniature cosmos. Now consider this. When physicists simulate universes on supercomputers, they don't recreate every particle. They approximate. They use rules, probabilities, and emergent behavior. The brain does the same thing in dreams. It doesn't simulate everything, only what matters. Background details are vague until observed. Peripheral objects blur. But central narrative elements are richly detailed. Exactly how simulation engines conserve resources. Some researchers suggest that dreams represent the lowest cost way to maintain a model of reality. Instead of constantly updating the model while awake, the brain refines it offline. Adjusts assumptions, tests variations, corrects errors. Which brings us to memory. Dreams are deeply intertwined with memory consolidation. During sleep, the brain replays fragments of the day. Moments you noticed, moments you ignored, emotions that lingered. But it doesn't replay them accurately. It remixes them, blending experiences into new contexts, as if stress testing memories inside alternate realities. This remixing is not random. Emotional intensity determines priority. That's why dreams often feel symbolic, not because they hide secret meanings, but because the brain compresses information into emotional shorthand, just like data compression. Now here's where it gets strange again. The brain doesn't distinguish much between imagined experience and real experience at the neural level. Fear activates fear circuits, regardless of source. Joy activates joy. Loss feels like loss. In dreams, emotions are real, which means the learning is real. From the brain's perspective, if it feels real, it is real. This challenges a core assumption we make about reality itself. That physical presence defines truth. But for the nervous system, experience defines truth, which suggests that subjective reality may matter more than objective structure. Philosophers call this phenomenology, the study of experience as it appears from the inside. And dreams are one of the purest forms of phenomenology available, unfiltered by external constraints. Some thinkers take this further. They suggest that consciousness is not generated by the brain, but filtered by it. That the waking world is a constrained version of a broader mental reality. And dreams are what consciousness looks like when constraints loosen. This idea appears in multiple traditions. In Hindu philosophy, the universe is described as Maya, an illusion shaped by perception. In Buddhism, reality is said to arise dependent on awareness. In modern philosophy, thinkers like Bernardo Kastrup argue that consciousness may be fundamental, not matter. Science does not confirm these ideas, but it doesn't dismiss them either. Because consciousness remains one of the greatest unsolved problems in science. No equation explains awareness. No scan reveals subjective experience. Dreams sit right at the center of that mystery. They are conscious experiences without external reality, meaning awareness does not require the physical world to function. So if awareness can exist inside a dream, what does that say about the nature of the universe you wake up into? You don't need to answer that. Let the question remain open, like a doorway that doesn't need to be entered. In the next part, we'll explore the boldest idea yet. The possibility that waking reality itself behaves like a dream, that the laws of physics resemble rules, that identity may be fluid, and that consciousness may be doing far more than observing. As the mind relaxes further, the boundary between dreaming and waking begins to soften, not in experience, but in understanding. Because the deeper scientists look into reality, the less solid it seems. At the smallest scales, the universe is not made of objects. It's made of probabilities. Particles don't have definite positions until measured. They exist as waves of possibility. This isn't philosophy. It's experimental physics. Before observation, reality is undefined. After observation, it becomes specific. This is not unlike a dream. Details appear only when attention moves toward them. Some physicists compare the universe to a calculation, not because it's artificial, but because information appears to be fundamental. Space and time may emerge from informational relationships, not the other way around. In dreams, space and time also emerge. They don't exist independently. They exist because the simulation requires them. Now consider identity. In dreams, you are fluid. You can be yourself, and someone else, or no one at all. You can observe from inside a body, or outside it. Yet awareness remains constant. Neuroscience shows that the sense of self is a construction, a narrative maintained by brain regions stitching together memory, sensation, and intention. When those regions quiet down during sleep, identity loosens, which is why dreams feel immersive but unstable. Some philosophers suggest the waking self is no different, just more consistent, more reinforced, more socially synchronized. From this perspective, waking life could be described as a high-stability dream, not false, but constructed. This idea appears in the simulation hypothesis, the proposal that reality may be generated by underlying processes we do not perceive. Again, not proven, but increasingly discussed. Interestingly, if reality were simulated, the brain's dreaming ability would be a perfect evolutionary preview, a system capable of generating worlds inside a world. Now let's touch something even stranger: shared structure. Across cultures and individuals, dream themes repeat: falling, flying, being chased, losing teeth, being late. These motifs appear universally, which suggests dreams are not random. They follow deep patterns. Psychologists call these archetypes. Carl Jung believed they emerged from a collective unconscious. Modern neuroscience suggests they arise from shared brain architecture. Different explanations, same observation, which means dream simulations are not personal inventions. They are built from common templates, like multiple instances of the same engine. And then there's the question of false awakenings. Dreams where you wake up inside another dream. You brush your teeth, check your phone, begin your day, until something feels off, and then you wake again. This nested structure is fascinating, because it shows the brain can simulate the experience of waking itself. A simulation of exiting a simulation. Some people report chains of these awakenings, 3, 4, 5 layers deep, each one convincing, each one real until it isn't. This leads to a quiet but profound insight. The feeling of "this is real" is not proof of reality. It's a mental state, which means certainty itself is generated, and that certainty can exist in dreams. You might notice now how gentle this realization is. Not frightening, just humbling. Reality doesn't disappear. It simply becomes more mysterious. In the next part, we'll explore the final layer. What dreams may reveal about consciousness itself. Whether awareness is local or universal. And why some scientists believe consciousness may be doing the simulating, not the brain alone. There is one question that quietly sits behind every theory we've explored so far. What is consciousness actually doing? Is it produced by the brain? Or is the brain shaping something that already exists? Most modern neuroscience operates under the assumption that consciousness emerges from neural activity. Neurons fire. Networks synchronize. Experience appears. This model explains many things, but not all. It explains correlation. It does not yet explain subjective experience. Why it feels like something to be you. Why awareness has a first-person perspective. Why experience exists at all. This is known as the hard problem of consciousness. And dreams place that problem in sharp focus. During dreams, sensory input from the external world is mostly shut down. Yet consciousness continues, vividly, richly, sometimes more intensely than waking life. If consciousness were merely reacting to sensory input, dreams should be faint. Instead, they are immersive, which suggests that awareness does not require the external world to function. Some researchers propose that consciousness is a fundamental property of reality, like space, like time, like energy. This view is called panpsychism, the idea that all matter contains some form of experience, however simple. Under this framework, the brain does not create consciousness. It organizes it, focuses it, localizes it. Dreams then become moments where organization loosens, where consciousness flows without tight constraints, where experience becomes fluid. Other theories go further. They suggest that the universe itself may be conscious, that awareness is not something happening inside reality, but something reality is happening inside of. This idea appears in both ancient philosophy and modern physics-inspired thought. In Vedanta, the universe arises from universal consciousness. In certain interpretations of quantum mechanics, observation plays a central role in reality structure. Again, none of this is proven, but none of it is dismissed either, because no experiment has yet ruled it out. Now consider dreams from this perspective. If consciousness is fundamental, then dreams are not simulations created by the brain. They are experiences unfolding within consciousness, shaped by neural constraints. The brain becomes a filter, a lens, not the source. This could explain why dreams sometimes feel meaningful in ways that defy logic, why insights appear, why emotions surface that waking thought avoids. It may also explain why some people report lucid dreams with extraordinary clarity, moments where awareness becomes self-reflective inside the dream, consciousness recognizing itself within its own simulation. Lucid dreaming fascinates neuroscientists because it blurs the line between waking awareness and dreaming experience. It suggests that awareness can operate independently of state. Some lucid dreamers report the dream responding intelligently, scenes stabilizing, characters reacting as if autonomous, which raises unsettling questions. Is the dream world passive or interactive? Neuroscience says it's internal. Philosophy says that doesn't settle the mystery. At this point, you might notice something. None of these ideas demand belief. They invite contemplation. Like stars you don't need to reach, only observe. In the final part, we'll bring everything together. Dreams, simulations, consciousness, reality, and we'll end not with an answer, but with a perspective that allows rest. For now, stay where you are. Nothing needs effort. Awareness continues on its own. By now, you may notice something subtle. The question we began with has slowly changed. It's no longer only about dreams. It's about reality itself. Are dreams simulations? Yes, in the sense that they are internally generated worlds governed by rules, populated by experience, and felt as real while they last. But that answer is incomplete, because waking life shares more with dreams than we once believed. Both are constructed. Both rely on perception. Both exist only when experienced. Science tells us that the brain never directly perceives reality. It predicts it. It models it. It fills in gaps. What you see, hear, and feel is not the world itself, but the brain's best guess. A continuous simulation, updated moment by moment. Dreams are not an exception. They are a revealed version of the process. A place where the simulation runs without external input, which means dreams are not strange. They are honest. They show us how experience is built, how reality is assembled, how meaning emerges from signals and silence. So are dreams universe simulations our brains are running? In one sense, yes. They are private universes unfolding behind closed eyes, governed by memory, emotion, and imagination. But in another sense, dreams may simply be what experience looks like. When the rules loosen, when gravity becomes optional, when time bends, when identity softens. And waking life may be what experience looks like. When the rules tighten. When consistency replaces possibility. When shared agreement stabilizes reality. Neither is more real. They are different expressions of the same process. Awareness encountering structure. There is no sharp line between dream and waking, only a gradient of constraint. And perhaps that is the most peaceful conclusion of all. That reality is not something you must figure out. It is something you are already inside of, experiencing, moment by moment. Tonight, your brain will build worlds again, not because it is confused, but because it is doing what it has always done best. Exploring, predicting, imagining. You don't need to watch. You don't need to control it. The simulation knows how to run itself. Thank you for spending this time with Science for Sleep. If you enjoyed this journey, you can subscribe for more calm explorations into consciousness, physics, and the mysteries that sit quietly beneath everyday life. For now, there is nowhere to go, nothing to solve, only experience gently continuing. And when the next dream arrives, you'll know you've been here before.